Alright, so this video is about vectors. This is the first of several videos about vectors. If you have taken physics before, you certainly know what a vector is. And if you haven't, and you're just now hearing about vectors for the first time, your question might be, why do I need to know what vectors are? Um, well, and this is a question that math teachers get all the time about different topics in math, but I can tell you pretty definitively that when it comes to the physical sciences, so those are things like physics, and then basically any branch of engineering, there is no more applicable mathematical concept than vectors. Let me give you an example. Here's a video of this was the first Falcon Heavy launch. SpaceX has on their right now as of October 2020. Their most powerful rocket is Falcon Heavy. It consists of 3 boosters, and this was their first ever test flight. This actually happened while students were registering for classes in 2018 at my high school. It was pretty amazing, and I was live streaming it from my phone. But these rockets come down, and they'll enter the top left frame, and they're coming from outer space, and they're landing within seconds of each other, precisely in the middle of these landing pads. And all of this stuff, this might sound a little hard to believe, but this was all made possible by vectors. Now, very complicated vectors, far more complicated than what we're going to get into here, but, 3-dimensional vectors where you have gravity pulling these very heavy things down from outer space, and you need to apply a vector in the opposite direction to make sure that it comes down and lands nicely. And you need to adjust the amount of force that you're applying in the opposite direction. The amount, when we talk about vectors, is something called a magnitude. You also need to make sure that the angle of that vector, the angle of that force, the direction of it, is in the right direction to make sure it doesn't flip all over the place. Here's an illustration of that too. This is a Star Hopper. This is a very early prototype of SpaceX's even more powerful, proposed Starship. And so you can notice the exhaust there of that rocket engine. It kind of changes direction, and as it changes direction, it changes where the spaceship, this little thing, goes. Right, so that is an example of a vector. That thrust has a magnitude and a direction. Okay, this works. I mean, this is not just. It's not just doesn't just have to do with rocket ships. It has to do with bridges. It has to do with optics. It has to do with essentially almost everything. Okay, vectors are very important. So, when it comes to math, how do we go about understanding vectors? Well, we represent vectors. This is kind of a geometrical representation of a vector. It's like a line segment, okay, but it's a non-terminated line segment. That's not a very good way of explaining that. Sorry. It's a directed line segment, so it's going in a certain direction. That arrow indicates that it's heading off that direction, and the length of that arrow indicates the magnitude of it. And we can call vectors different things. We can give them different letters, and just we put these little arrows over the top of them to indicate that they are vectors. So here we have 3 vectors drawn on the screen: vector m, vector h, and vector r. And we've added vector m and vector h. And something that's very important to notice here is that when we add vectors, we add them tip to tail. So the tip of vector m, we put the tail of vector h on it to add it, and that resultant vector, vector r in this case, is the sum of those 2 vectors. Notice that if I did h first, so if I put h over here and then added m, we end up in the same place. So you can imagine if I had 2 vector m's, right? So if I had one over here and I had 2 vector h's and one over here, to illustrate both of the different ways I can get that end result, you see this little parallelogram that gets drawn with the 2 vector m's and the 2 vector h's. This is actually a property of addition when it comes to vectors. It's called like the parallelogram property of addition. But essentially all it means is that it doesn't matter in which order m and h come, we still get the vector r produced. That's known as the associative property of addition. It doesn't matter not the associative property of addition, the commutative property of addition. It doesn't matter which way you add, you still get the same sum. Okay. it would make sense then maybe that if we multiplied vectors by -1, we're just changing the direction of them. Just like on a number line, if we have the number 5 and we multiply by -1, now it's the other side. It's the opposite side of the number line. We'll multiply a vector by -1. It reverses the direction. Okay, so from the previous slide, okay, uh, vector h was kind of going down to the right. When we multiply by -1, now it's going up the left. Same magnitude though, just opposite direction. Okay, and same deal here. We still have addition of vectors. So if I moved vector m over here and I moved vector h over here to essentially add negative vector m to negative vector h, I'd still get the negative vector r. Um, so what that tells us is this really important piece of information about vectors when it comes to adding them. And this is all going to seem pretty abstract right now, but if we had vector v and vector w, that's the same thing as vector w plus vector v. Okay. We can also use the associative property of addition. The associative property and commutative property of addition are very similar. Associative properties has to do with grouping. Additive identity means if you add 0 to a vector, just like the additive identity of period is just when you add 0, it doesn't change something. And then the inverse identity is when you add the opposite of something, you end up with a sum of 0. So the next video you're gonna see, the topic of that video is going to be how do you actually add the vectors though, right? Like what are the components of a vector and what does it look like when you add them? What does it look like when you do multiplication with vectors? And it's all actually a really straightforward process. And so hopefully this video illustrates, first of all, what a vector is and why they're important.